In a time when nations around the globe are in a fierce race to strengthen their defense systems and maintain technological superiority, Elon Musk has unveiled something that could completely rewrite the rules of modern aviation, a revolutionary anti-gravity fighter jet. This extraordinary machine, introduced at a critical moment in global history, doesn't just represent another step forward in aerospace, signifies a monumental leap into the future of flight. The implications of such a creation are vast. What could this mean for the world's air forces? How does it change the balance of power? And what are the real capabilities hidden behind this astonishing piece of technology? Join us as we explore the rise of Elon Musk's anti-gravity aircraft and the deeper meaning behind his most recent engineering triumph. Just before the anti-gravity fighter jet's debut, another of Musk's groundbreaking projects was making headlines: the SpaceX Starship rocket. During its third major test flight, Starship reached new milestones that brought humanity one step closer to interplanetary travel. The massive two-stage rocket launched from SpaceX's facility in Texas, aiming to send its upper section around the globe for a planned re-entry over the Indian Ocean. While the mission ended with the loss of radio contact before the final splashdown, the progress achieved was extraordinary. SpaceX described it as one of the most successful test flights yet. Elon Musk himself expressed immense satisfaction, noting that despite some setbacks, this flight demonstrated just how close they were to realizing Starship's full potential. This was a major improvement over previous attempts. In earlier launches, specifically in April and November of the previous year, the enormous 20-meter-tall rocket exploded shortly after liftoff. This time, Musk and his SpaceX team were determined to achieve better results, and they did. The rocket ignited with a thunderous roar, powered by its 33 Raptor engines, sending shockwaves across the launch site as it lifted off in perfect synchronization. Every stage of the flight unfolded almost flawlessly. About 2 minutes and 44 seconds after takeoff, the massive lower section, known as the booster, separated cleanly from the top section, referred to as the ship. From that point on, the ship continued its journey high above Earth, gliding gracefully over the Atlantic Ocean and then over the African continent. Cameras mounted on the vehicle captured breathtaking footage of our planet from more than 100 miles above the surface, a sight that looked almost unreal. But the most critical phase was yet to come: the re-entry. The spacecraft had to withstand the brutal heat and stress of returning through Earth's atmosphere before attempting a controlled descent into the ocean. As the ship began its fiery re-entry, the cameras showed the spacecraft enveloped in plasma-glowing haze of superheated gases. Moments later, radio contact was lost, and ground control could only watch as telemetry data vanished. Engineers later confirmed that the ship had likely broken apart during the descent. The booster faced its own challenges. It was supposed to slow down and perform a soft landing in the Gulf of Mexico near the Texas coast, but it appeared to descend too quickly, ultimately failing to make a safe splashdown. Engineers will analyze the data to determine the cause. But despite these issues, the overall outcome was still seen as a tremendous success. After all, this was a test flight, and the progress was undeniable. Starship's performance has set new records in aerospace history. The rocket's 33 engines produce a staggering 74 meganewtons of thrust, making it far more powerful than even the legendary Saturn V rockets that carried astronauts to the moon in the 1960s and 70s. SpaceX engineers believe that once perfected, Starship will be a total game-changer. Unlike traditional rockets, which are discarded after use, Starship is designed to be fully reusable, capable of being refueled, inspected, and relaunched in rapid succession. So it's like a commercial airplane. This innovation alone has the potential to reduce spaceflight costs by orders of magnitude, opening the door to frequent and affordable access to orbit and beyond. Starship's vast payload, capacity over 100 tons per launch, means it could transport not just satellites but also entire structures, habitats, or even human crews to the moon, Mars, and other destinations in deep space. For Musk, this isn't just another engineering challenge. It's part of his grand vision for humanity's future, a future where humans become a multiplanetary species. In the shorter term, Starship plays a crucial role in supporting Musk's Starlink project. With more than 5,000 satellites already in orbit, Starlink is creating a global broadband internet network that can reach even the most remote corners of the planet. The Starship rocket will allow SpaceX to launch even more satellites at once, further expanding and upgrading the constellation. During this most recent flight, engineers successfully tested the opening and closing of a new deployment door designed specifically to release Starlink satellites into orbit, another step toward full operational readiness. But the Starship program's ambitions stretch far beyond Earth's orbit. Musk has long dreamed of using the rocket to send humans and cargo to Mars, where he envisions establishing a permanent settlement. This dream aligns with NASA's goals as well. The U.S. Space Agency has partnered with SpaceX through its Artemis program, which aims to return astronauts to the Moon later this decade. NASA plans to use a modified version of the Starship as a lunar lander, capable of ferrying astronauts from lunar orbit down to the Moon's surface and back again. Before that can happen, though, SpaceX must demonstrate Starship's safety, reliability, and ability to perform multiple flawless flights. NASA hopes to see those milestones reached by late 2026, following every SpaceX launch. The Federal Aviation Administration (FAA), the regulatory body overseeing commercial spaceflight in the United States, conducts an investigation, especially when anomalies occurred during flight. The recent Starship mission is no exception. The FAA will review the booster and ship's performance, working alongside SpaceX engineers to understand what went right and what needs refinement. This kind of post-flight analysis is standard in aerospace development, and it's through this rigorous process that SpaceX continues to improve its designs. The story of SpaceX's success didn't begin with Starship, of course. It began with a far smaller rocket, the Falcon 1. This was the first privately funded, liquid-fueled rocket ever to reach orbit, a milestone that changed the history of space exploration. At the time, SpaceX was still a young company with limited resources, but Musk's vision was clear. He wanted to create a new generation of rockets that were affordable, reliable, and reusable. Falcon 1 was the testing ground for that vision. The rocket was built to be simple, yet powerful. The first stage was constructed from lightweight aluminum alloys and powered by a single Merlin engine. It even included a parachute system for safe recovery after flight, a concept that foreshadowed SpaceX as later innovations in booster reuse. Over time, the Merlin engine was improved, culminating in the Merlin 1C version, which generated about 92,000 pounds of thrust and burned for nearly 3 minutes during ascent. The second stage of the Falcon 1 used a Kestrel engine, smaller and optimized for operation. In the vacuum of space, it produced around 7,000 pounds of thrust and featured a pressurization system to control propellant flow. The entire design philosophy behind Falcon 1 was to make orbital launches cheaper and more accessible. When it was introduced in 2005, the launch price was just $5.9 million, a fraction of what competitors were charging at the time. As the technology advanced, so did the costs and capabilities. By 2006, the price had risen slightly to $6.7 million, and by 2009 to around $7 million. SpaceX even offered discounts for customers booking multiple launches. The Falcon 1 could carry small payloads, initially around 600 kilograms too low Earth orbit, but later versions were limited to 420 kilograms. As costs increased to around $9 million per launch, even so, the rocket's success proved the concept and established SpaceX as a legitimate player in the global aerospace industry. After 5 total launches, Falcon 1 was retired in 2009, but its legacy lived on through the Falcon 9, a larger, more powerful 2-stage rocket designed to carry heavier payloads and eventually human crews. The first Falcon 9 launch took place on June 4, 2010, marking the start of a new era for the company. Just 2 years later, in October 2012, SpaceX achieved another historic milestone by sending a Falcon 9 to resupply the International Space Station, making it the first private company ever to do so. As the technology advanced, so did the costs and capabilities. By 2006, the price had risen slightly to $6.7 million. And by 2009, to around $7 million. SpaceX even offered discounts for customers booking multiple launches. The Falcon 1 could carry small payloads, initially around 600 kilograms too low. Earth orbit, but later versions were limited to 420 kilograms. Its costs increased to around $9 million per launch. Even so, the rocket's success proved the concept and established SpaceX as a legitimate player in the global aerospace industry. After 5 total launches, Falcon 1 was retired in 2009, but its legacy lived on through the Falcon 9, a larger, more powerful 2-stage rocket designed to carry heavier payloads and eventually human crews. The first Falcon 9 launch took place on June 4, 2010, marking the start of a new era for the company. Just 2 years later, in October 2012, SpaceX achieved another historic milestone by sending a Falcon 9 to resupply the International Space Station, making it the first private company ever to do so. From there, Falcon 9 became the backbone of SpaceX's operations. In 2020, it became the first commercial rocket to send astronauts into orbit. And by 2021, it held the record for the most launches of any U.S. rocket in history. The vehicle's safety record is also among the best in the industry. With hundreds of successful flights and only a handful of in-flight anomalies, its reusability, once considered impossible, has been demonstrated time and again. With many boosters being recovered and reused multiple times, each launch of a Falcon 9 or Starship not only advances technology, but also lays the foundation for Musk's larger vision. A world where the boundaries between Earth and space are as easy to cross as flying between cities. The innovations behind these rockets, like reusable engines, modular construction, and cost-efficient design, also serve as the foundation for the next great leap. Anti-gravity propulsion. It's within this broader context that Musk's anti-gravity fighter jet comes into focus. While SpaceX continues to conquer space, Musk has been quietly developing new propulsion systems that could completely redefine how aircraft operate within Earth's atmosphere. The anti-gravity jet represents the merging of aerospace, artificial intelligence, and advanced materials technologies honed through SpaceX, Tesla, and Neuralink brought together to create a craft capable of flight without relying on conventional thrust, unlike traditional jets that depend on engines burning massive amounts of fuel to generate lift and forward momentum. This new system manipulates gravitational and electromagnetic fields to achieve propulsion. In essence, it defies the rules that have governed aviation since the Wright brothers' first flight. Its ability to hover silently, maneuver instantaneously, and reach extreme altitudes with minimal energy expenditure could revolutionize both civilian and military aviation. This kind of innovation couldn't have come at a more crucial time. Around the world, nations are pouring resources into next-generation aircraft, hypersonic weapons, and autonomous defense systems. Musk's entry into this field threatens to upend decades of military aviation dominance by traditional manufacturers. If his anti-gravity jet performs as expected, it could render existing aircraft obsolete overnight. The implications extend far beyond defense. Such technology could be adapted for passenger transportation, cargo delivery, or even planetary exploration. A vehicle that can take off vertically, travel at incredible speeds, and land anywhere without a runway would make global travel instantaneous and dramatically reduce carbon emissions compared to conventional jet engines. For Elon Musk, this isn't just about innovation, it's about changing humanity's trajectory. His vision has always centered around solving the biggest challenges facing civilization: energy, transportation, and sustainability. From electric cars and solar power to reusable rockets, and now anti-gravity propulsion, each invention builds upon the last, forming an interconnected ecosystem of technologies designed to make life and beyond Earth more efficient, equitable, and free from the limits of fossil fuels as the world watches. The unveiling of this anti-gravity aircraft marks the dawn of a new technological age. It's a reminder that innovation often comes not from government agencies or defense contractors, but from individuals willing to dream bigger than anyone thought possible. Elon Musk's anti-gravity fighter jet may have started as a vision of advanced defense, but its ultimate impact could reach far deeper, changing how humanity perceives motion, travel, and the very laws of physics themselves. And as history has shown, every time Musk sets his sights on an impossible goal, the world ends up changing in ways no one could have predicted. From the humble Falcon 1 to the mighty Starship hand now, possibly to an aircraft that can defy gravity itself, this journey is not just about engineering. It's about redefining the limits of what humans can achieve. The question now isn't whether the anti-gravity era will arrive, but how quickly it will reshape the future of flight forever.